Today's concept is equilibrium of force. This is a very important concept, and very often you will find this equilibrium in mechanics. I am Datta sir. I am actually making videos on various concepts of physics for the benefit of students, particularly for those who are appearing in IIT JEE for admission to IITs. So this particular concept, which is called equilibrium, it needs some elaboration, because unless you are very much clear about it, you cannot deal with it. That's why I would request you to please listen to this video very carefully. Let me go to the topic. Now, what is meant by equilibrium? Equilibrium means if on any body several forces are acting and the net force becomes zero, that means there is no force. Net force is zero. That is called a equilibrium condition. Of course, this is a translational equilibrium. There is a separate equilibrium for rotational equilibrium that will be dealt with in rotation chapter. Here in this fourth chapter, we are dealing with this type of equilibrium, which is actually force equilibrium, equilibrium of forces. Now, force is a vector, you know that, and force can be resolved in x, y, z direction. So there may be three components of force. Now, on a body, there may be several forces and all may be resolved in three directions. And if we find in a particular direction, suppose in x direction, net force is zero, it is not necessary that it will be zero in y direction or in z direction. It may not be, maybe or may not be. So if it is only zero in one direction, we call that there is equilibrium in that direction. In other direction, there is no equilibrium. So this equilibrium is very much directional. Means in a particular direction, if the net force is zero, then we call it equilibrium. Now, what does the Newton's law says? First law says if no force is acting on a system, then if it is at rest, it will be at rest. If it is moving, it will be moving with uniform velocity. Means acceleration will be zero. So that is the first law. So if in a particular case there is equilibrium, that means force is zero, that means ultimately no force is acting, then it will be either at rest or moving with uniform velocity. This tallies with the statement of first law. So that means there are two types of equilibrium then. It may be either at rest or it may be moving with a constant velocity. When it is at rest, we call it a static equilibrium. When it is moving with constant velocity, we call it a dynamic equilibrium. And both the equilibriums are equilibrium of forces. So, to recapitulate, it is the situation when net force is zero, and it may be in a particular direction also. In the particular direction in which net force is zero, we call equilibrium in this direction. In other direction, it may not be zero or may be zero. And there are two equilibrium, static equilibrium and dynamic equilibrium. Now, that is a special case where suppose three forces are acting on a body, and these three forces are in equilibrium. That means sum of the three force, means vector sum of the three force is zero. Then only it becomes equilibrium. Three forces are in equilibrium means their vector sum or resultant is zero. In that case, if their mutual angles, means angle between two vectors is given by A, B and C. There are three angles because there are three forces. And if the vectors have magnitude small a, small b and small c, we can write A by sin A by equal to B by sin B equal to C by sin C. This is called Lami's theorem. There is a proof of it. I am not going to the proof. That is there in every book. So I am not going to the proof. I am just telling you that it is there. Now, suppose these three forces are three vectors. We know by the triangle law that in a triangle ABC, if AB and BC are two forces which are taken in the same order, then we write AB plus BC equal to AC. That means AC is taken in reverse order. From this equation, we can write AB plus BC minus AC equal to 0, or AB plus BC plus CA equal to 0. Minus AC is nothing but CA. That means if we draw this triangle again, we will get the diagram below. In that case, AB, BC and CA are all in same order. You just note. Earlier AC was in reverse order, but CA is in same order. That means if when the forces represent three sides of a triangle, suppose three forces, it applies only three forces. When three forces are represented by three sides of a triangle and they are taken in the same order, then their sum is 0. Their sum becomes 0, as we have we have got in the above equation. So in that case, they will be in equilibrium. That means we can say that if AB, BC and CA are three vectors which can be represented by three sides of a triangle, all taken in same order, then they are in equilibrium. This is in case of a three forces. Similarly, we can extend this. If there are four forces, we can take a rectangle. They are also, if they are represented by four sides of the rectangle taken in same order, they will be in equilibrium. If it is a pentagon, then also if they are in same order, their sum will be 0, they will be in equilibrium, like this. So that means when they are taken in same order, their sum will be 0. They are equal. This is all about force equilibrium. And again remind that there are two equilibriums called static equilibrium and dynamic. You will find this type of cases very often in mechanics. I hope you have learned this. If you are benefited by this, please like this video, share this video and subscribe to my channel, because I will be posting this type of videos on various concepts where you struggle for your benefit. Also, if you want any particular topic to be discussed, you can let me know in your comments. Thank you very much.